Okay. So now, so we saw all this, how this trigonometric function is represented in the graphs. Okay. So let us write down. Let me draw the what we had. So this is x minus x, y minus y. So for any point, I take any point on this coordinate system, okay, and let that point be p x comma y, okay, and let this distance be r, okay. Then we know sine theta. Now this is not unit, okay. So then we know sine theta is equal to y by r and cos theta equal to x by r, okay. Or I can always write it. Therefore, from here I can write x equal to r cos theta and y equal to r sine theta. Okay, so now in the place of x and y, I can always use r and theta. Okay, so then, and when because then if I am going to represent any point in the place of x and y, I am going to represent by r and theta. So I am going to give another plot. Okay. Okay, sorry. This plot won't be look like this, and let me make up a plot. So then I can always give a plot, something like a line, and okay. So I am going to make theta here. Okay. So what will be the angle of theta? How much it can go? 360 only. 2 pi, right? Because I am going to repeat the same thing. So this is going to go from 0 to 2 pi, okay, and r can go up to infinity, correct? R. So then any point here, similar to what we had x comma y, any point p will be r. Sorry, okay, I would make it like this. So r theta. So let me take theta here and r here. So this is going to be r. And this is theta, and that will be 2 pi. Okay, after 2 pi, it's going to make that. So any point P will be r comma theta. Correct? So how am I going to connect these 2 points? If I give any point in r and theta, then the equivalent point in xy system will be by this. X equal to r cos theta, y equal to r sin theta. By this way, I can represent a point can be represented in xy axis or in your r and theta. Okay, so this is we call as your Cartesian coordinates or rectangular coordinates, and this is called as your polar coordinates. Or circular. Okay, and this is interesting. Why this coordinate systems are interesting? Okay, so now if you see, one thing is, yeah. So your y can go as long as to infinity. Okay, now before that, let me explain something. Why these two coordinates we are using is where some problems will look simpler in this coordinate system and some problems look simpler in this coordinate system. So let us see what are the problems. Suppose in this coordinate system, in the rectangular coordinate system, I am having a line parallel to x-axis, okay, passing through a point, say let us see 2. So what is the equation of this line?
So
Y equal to 2, correct? It's the same line. So I can have another one line from here which passes through -1. Then I can write here y equal to -1. Simple. Similarly, when I have any line parallel to your y-axis passing through a point, say let us say 5. So then I can have x is equal to 5 is the equation of the straight line. I can do all those things. So basically kind of all rectangles. So if I have this as minus 2, x is equal to minus 2. So this is a in a rectangle. So now if you have all these lines parallel to the axis, okay, so then this equation of lines is becoming simpler. And yeah, so now, so let us try to see what happens if I draw these lines parallel to the axis in this system. So I am going to, suppose let me take a line parallel to theta axis along this. What it says, your r, say r equal to say something around 2, r equal to 2. So in a circle, so the equivalent representation here, what it will be? Tell me. So r, right? So r equal to 2 means this is nothing but a circle, because theta can be for all theta, r is a 2. Is that right? Okay, so a line parallel to your theta axis in polar coordinate system is a circle in a rectangular coordinate system. Okay, otherwise if you want to represent a circle in a rectangular coordinate system, this equation is going to be not very straightforward. This equation is going to be quadratic, x square plus y square equal to r square. Okay, that comes from here. Sin square theta plus cos square theta equal to. So this gives you the equation. So here your equation is a quadratic. So but rather here I can always write r equal to 2 means it is basically a circle. So now r equal to say something like 3 or r equal to 5. So what it will be? It's another concentric circles. Correct? So there is going to be another circle of radius. So this radius is going to be 5. Okay. So this is the so that's why this was called a circular coordinate system, because any constant line of r is going to become a circle in the Cartesian coordinate system. So let us take let us try to see this also. We will take a line parallel to r, that means certain theta. Okay, this means I am going theta, let us say theta equal to what is the angle we can take? So let us take pi by 4. This is pi by 4. That means here pi by 4 is 45 degree. Correct? So what this means? Tell me. Theta equal to pi by 4 here in a Cartesian coordinate, how it looks like? It is just a straight line. This is theta equal to pi by 4, correct? And for all r, it can keep on going. Okay? So if I draw another line, so this will be less than theta pi by 2. Goes like this. So all the lines, all possible lines if I draw, it will be like a, you got it? So any line parallel to r will be a line in the Cartesian, it will be going diverging from the origin. Okay, circularly. Okay, so that's why this coordinate system is called as your circular coordinate system or polar coordinate system. And what happens sometimes, all the problems when you go in your higher studies, when you're having the different problems, okay, certain problems look simpler in a Cartesian coordinate system. Okay, so if you have what they call a circular symmetry, if it's anything is circle, something kind of circle if you're getting, then what happens, always jumping to a polar coordinate system will make the problem simpler. That's why you have to use a 2 different coordinate system. And there's a lot of very interesting thing when you jump from one coordinate system to another coordinate system. So the point is, because here in the Cartesian coordinate system, your y goes from plus infinity to minus infinity, it can go, correct? And x also can go. But here it can't. R cannot be negative. R will be only positive infinity, it can go up to infinity. Whereas theta can no way go into infinity. You got it? Because it stops at 2 pi. Okay, any angle can go all the way to 2 pi. So, and that's what, see, that's what even the infinities, depending upon what the number of infinities you get, it depends upon the coordinate system. So sometimes when you do in a certain problem in some coordinate system, you will find it in infinity, and when you suddenly change the coordinate system, you will see the infinity will vanish. Okay, so this all you will see it in a higher class, higher education, you will go through it. Okay? Yeah, that's what your polar coordinate.